Hi everyone, and in this video we're going to be looking at question 4 of the 2012 Specialist Mathematics Examination paper. So this paper focuses on a few core vector geometry questions, and it involves calculating the magnitude, the dot product, and being able to use a few conceptual skills to be able to solve a problem here. So we're given two different vectors there, and they've been specified in the brackets. We're given A and B, and we're asked to find, in the first part, the magnitude of B. So simply we take each component there and we summate them, and summate the squares, and then take the square root of that, because that's how we find the magnitude of a three-dimensional vector, and we end up with the magnitude of B being equal to 3 units there. Next, we're asked to find the dot product, A dot B. In order to find A dot B, we simply take the x components, we get their product, then we add that to the product of the y components of each vector, and we repeat for the z component, and we end up with the dot product being equal to 9. Now we start getting on to the fun stuff. So what we're asked next to do is show clearly that the angle between A and B, as we can see in this little figure here, and we're given vectors A and B before, is pi on 4. So we've got to show it's pi on 4 radians, so 45 degrees. And we know that one equation for the dot product is A dot B is the product of the magnitude of A, magnitude of B, multiplied by the cosine of the enclosed angle. So what we can do is we can rearrange this equation such that we have cos theta is equal to A dot B on mod A multiplied by mod B. Substituting in A dot B from AII just above, we put in 9, and then we know that the magnitude is 3, the magnitude of B. We can easily work out the magnitude of A. We simply, as we did before, when we're working out the mod of B, for the mod of A, it's just 1 squared plus 4 squared plus 1 squared. We take the square root of that. It's going to be square root 18. And so when we simplify, we know 9 divided by 3, as we can see in here. 9 divided by 3 is simply going to be 3 in the numerator, divided by square root 18. Well, what we can do is we can rewrite that as 1 on square root 2, because we can rewrite square root 18 as being 9 times 2. So we get the 3 out the front there, and we're left with 1 on root 2 as what's remaining in its simplest form. Well, if you know your unit circle, you know that's going to be pi on 4 radians, but if you're not that familiar with it, which is unfortunate, but that might be the case, you can always take the inverse cosine of 1 on square root 2, and you find that's pi on 4 radians. So we've effectively shown that. Okay, so now we're getting on to the last bit here. For the first page anyway, it does go on to for another page, but we're asked now to have, we're given a point and we're asked to find the points M and N such that the angle MAN, as we can see in the figure here, MAN, is going to be pi on 4 radians. So in order to do this, we want AM and AN to have the same length as A and B, and obviously we want the dot product to be the same. So we need their magnitudes and their dot product to be the same in order for that to be the case, because we want pi and 4 radians between them. So M is equal to, and we have the x component, y component, and z component of M in the vector there. Take our point A that was given in the question, because that's our starting point, and that needs to be equal to our original A vector, because that's going to be our magnitude there, which is important for the vector, because of course the dot product, we need that to be the same dot product, the same A dot B value and the same magnitude in order for this to be pi on 4 radians from the previous section. And we do the same for N. After finding M, we find M to be 401. That's simply an exercise in simple vector subtraction there. And we can find N using a similar approach. We just use the B vector, and we find that M is 401 and N is 2, negative 2, 0. So now we start getting on to some more of the conceptual stuff. So we're asked to show that the vectors Those two there at an angle of pi on 4, what we do is we work out the magnitude of both, and we see that they're both the same as what we had before. We have one that's square root 18 units in length, one that's 3 units in length. We work out c dot d and we see that's 9, so we can write cos theta as being 9 on 3 square root 18. Well, we know using our result from c on the previous page, and even b as well, that we find the angle to be pi on 4 there. So because we've shown that cosine theta is equal to that, we know using our result, we can say, well, that's 1 on square root 2, and we know from before that that's that answer there. So the last part here is a really good conceptual kind of question, and it does take a little bit of playing around with. You've got to consider two things with this. You've got to consider that the magnitudes have to obviously be square root 18 and 3 for this to work, for the two vectors, but then you also need their dot product to equal 9 as well, so we get this nice simplification down to 1 on root 2. So as you can see, I tried two vectors here before going on to these, which this one here works when we look at the dot product and we look at their magnitude. But I tried just moving the numbers around in any odd fashion, and while their magnitudes are square root 18 and 3 respectively, their dot product is not 9, so it wouldn't work in this context. You can go through and you can do the calculations, but you end up with a different value on top there, so it won't simplify down to 1 on root 2. So you've got to sort of play around a bit with the numbers, such that you can get a dot product of 9 as a dot b, or in this case g dot h, as I obviously went through all the letters here trying to get this. So hopefully this video has been helpful. This is question 4 of the 2012 Specialist Mathematics Examination. Thanks for watching. I think this is a pretty cool question. If you've got any comments, leave them below.